Other forms of atmospheric pollution, such as the exhausting of carbon dioxide, methane and ozone, contribute greatly to climate change.
Well, I think basically it's often the case that our models, which are extremely complex and good tools, often don't necessarily have the right physics or chemistry in them to be able to predict what's going on in the future. So a lot of the time in atmospheric science we've been making discoveries. Back in the late 19th century, early 20th century, the discovery of the stratosphere was a complete surprise at the time, or fairly surprising. The fact that temperature increases above the tropopause. This was a surprising discovery, and really that's been typical. We didn't expect summer smog. We don't understand why in Paris there was a really big smog a couple of years ago in spite of improvements of legislation. This winter we had in London a smog which is maybe being attributed to excessive wood burning recently. So there's a lot of things although we're getting over the last 25 years much better information, but the satellites in particular tell us ultimately, or could tell us ultimately, what the source strengths are and enable us to follow the information, and thereby, together with models, give really good prediction for people about the air quality that they're receiving.
The Copernicus program is very important for Europe and for the world. First of all, the Copernicus program is providing free data to everyone at any place in the world. So many users, not only in Europe, but also in America, in Asia, are using our data in a very large scale and very significantly. So therefore, Copernicus is really monitoring the health of our planet from all dimensions: the atmosphere, the oceans, the land surface, the ice caps, and this whole system of the Earth composed of these components is monitored constantly with Copernicus. And therefore it is really important to see what is the state of our planet and how it will evolve in the future.
Well, the data can be used for different applications. So for example, for the air quality forecasts. It's also used by KNMI, for example, for the UV forecasts. And we also use it to warn the aviation for volcanic ash plumes. On top of that, the data will also be used by scientists around the world to study the atmosphere and to study how man is changing the atmosphere over time. Continuous monitoring is very important, especially when you're looking at slow changes, and an overlap between the data is then really necessary to be able to glue these different data sets together to one data record. And we have data records from these kind of instruments starting in the 19th, for example, for the pollution. It's very important to maintain these valuable data records and to extend them into the future.
Well, the data is important for our climate research and also for our environment, because the air we breathe, it could be changed due to all sorts of pollution events. And then a second example is that we need to monitor our ozone layer. Since ozone is destroyed due to chlorofluorocarbons, Sentinel-5P will have also the role to monitor the further evolution of the ozone layer.
Mankind can halt the pollution of our atmosphere with good legislation. The European Space Agency, ESA, works tirelessly to monitor our planet and the air we breathe.
We need a future where we, with so many people on the Earth, are in a position to maintain a good quality of living for human beings, but also for the biosphere.